Hey there, physics enthusiasts. Did you know that you actually weigh a tiny bit less at the equator compared to the poles? That's gravitation at work, and it's full of surprises. Let's explore. So, what exactly is gravitation? In simple terms, it's the force that attracts any two objects with mass towards each other. This force is why apples fall from trees and why planets orbit the sun. It's super important for JEE, so pay close attention. Let's start with Newton's law of gravitation. This law basically tells us how the gravitational force between two objects depends on their masses and how far apart they are. The bigger the mass is, the stronger the pull. And the further they are, the weaker the force. Okay, let's define something important, the gravitational constant, often just called G. This is a fundamental number that tells us how strong the gravitational force actually is. It's about 6.674 times 10 to the minus 11. Remember that for your calculations. Now, let's talk about gravitational potential energy. This is the energy an object has because of where it is in a gravitational field. Think of it like this, the higher you lift a ball, the more potential energy it has, because gravity is pulling it down. Here's a key formula you need to know, U equals minus G times M divided by R. U is the gravitational potential energy. G is the gravitational constant. M and M are the masses of the two objects, and R is the distance between them. This formula shows you how potential energy changes with distance. Next up, we have Kepler's laws of planetary motion. These laws describe how planets move around the sun. The first law says that planets move in ellipses, not perfect circles. The second law says that planets speed up when they're closer to the sun. Here's Kepler's third law in formula form. T squared is proportional to r cubed. T is the orbital period, how long it takes for a planet to go around the sun. And r is the semi-major axis, which is basically the average distance of the planet from the sun. Here's a crucial point to remember for your exam, gravitational force is always attractive. There's no such thing as a repulsive gravitational force. It's always pulling things together, never pushing them apart. Keep that in mind. Let's work through an example problem. Imagine we have two objects, one with a mass of 10 kilograms and the other with a mass of 20 kilograms, separated by a distance of 1 meter. What's the gravitational force between them? Use the formula, plug in the numbers, and you'll get about 1.334 times 10 to the minus 8 newtons. Gravitation isn't just a theoretical concept, it's all around us. Satellites stay in orbit because of Earth's gravity. GPS uses gravity to pinpoint your location. And the tides are caused by the moon's gravitational pull. Pretty cool, right? Here are a few quick exam tips for you. First, always draw a free body diagram to visualize the forces acting on an object. Second, pay close attention to the units and make sure you are using the correct formula. And third, practice. So, to recap, we learned about Newton's law of gravitation and how it determines the force between masses. We explored gravitational potential energy and how it changes with position. And we discovered Kepler's laws and how they describe planetary motion. And remember, all of this, AI-powered notes, doubt solving, practice tests for gravitation, is completely free on Synapse. Study smarter, not harder. Ready to master gravitation for JEE? Start your free trial today at synapse.omups.in. And don't forget to subscribe to our channel for more helpful lessons. Thanks for watching.